or we switch?
We can continue with that.
Okay, very good. Good, so I'm on page 4. So again, we have the acceleration, so we have to use the notation v of t. Which function prime is sine t? Oh, sorry. Which function prime is sine t?
Negative cosine t.
Awesome. Which function prime is negative sine t? You know what I mean. I'm sorry. Okay. Good. So I don't have any condition for the velocity. I cannot find c on the way. I have to wait. So now s of t, which function prime is negative cosine t?
Negative sine.
Very good. Awesome. Which function prime is negative sine t? Very good. Which function prime is c?
Cx.
Very good. Awesome. Plus, which function prime is 0? So we determined this is what we call the most general antiderivative of a of t. But we don't want the most general because we are given two conditions, two initial conditions, specifically to enable us determine c and d. So let's start. But I could not use them here because it doesn't say anything about velocity. I am given two conditions for s. Okay, so then let's continue with this. S of 0 is 0. That's the first condition. S of 0 is 0, and S of pi is 6. Good. So I don't need that page anymore. Good. So S of 0 is 0 is. I plug in 0 here, and sine is 0. I plug in 0 here, but cosine is 1. I plug in 0 here, and this is 0. I cannot plug in 0 here, so it's plus d, and that equals 0. Very easy. D equals negative 1. I will rewrite with the given d, with the d we found, s of t negative sine t plus cosine t plus ct minus 1. Now I'm going to address the second initial condition. What does this equation say? When you plug in pi here, here, and here, you will get 6. Okay, fine. When I plug in pi here, this is 0, because sine is 0 left and right. When I plug in pi here, then I get negative 1. When I plug in pi here, I get plus pi c, and then minus 1. So pi here, 0. Pi here, negative 1. Pi here is this. Minus 1 equals 6. So negative 2 will go to the other side, so pi c will equal 8. So then c equals 8 divided by pi. So now I have both constants. So then s of t equals negative sine t plus cosine t, plug it in, plus 8 over pi t minus 1. And this is the unique, only one antiderivative of a of t equals sine t minus cosine t. It's the only one that fulfills the given conditions. There is no other. We were only asked to find the position of the particle with the given conditions. S of 0, 0, S of pi, 6. How are we feeling about this? Do we need more examples? Thank you,
Yeah,
Gab.
can we do another one of
Sure,
those?
of course, yes.
Thank you.
Anything, just choose.
Can we do 66?
Yes. So, no, I don't think that this is a good color. 66, very good. We have v of t equals t squared minus 3 the square root of t. And we are given that s of 4 equals 8. 66, you said, right? This one.
Yep.
Perfect. Good. So that's a good one. We are only asked to find the s of t, right? So when I see something like this, in order to get it ready for anti-differentiation, I will immediately write it as t squared minus 3t to 1/2. This will help me a lot. Since I have the velocity, I only have one given condition or initial condition, so I will only have one constant because this is the first derivative and this is the function. So then s of t. So then s of t is, for this function prime to be t squared, I have to increase the power by 1 and divide by that outcome. Same thing here, minus 3. I have to increase the power by 1 and divide by that number. Plus, what function prime is 0. I always have to think about that. At this point, this is the most general antiderivative. I have to clean it up a little bit. So then s of t is t to the third over 3, but I have to flip this into 2 over 3, and the 3's will go away. So minus 2t to 3/2 plus a constant c. I am given the initial condition. I am told that s of 4 is 8. So when I plug in 4 here everywhere, I have to get the answer 8. I don't need this anymore. It's in the way. Good. So when I plug in 4 here, 4 to the third, I think it's 64. Correct me at any point in time. This one I have to be careful because it's the square root of 4, which is 2. 2 to the third is 8, so negative 16, plus a constant c. So one more time, 4 to the third, 4 times 4 is 16, 16 times 4 is 64, divided by 3. Here, so this is t to 3/2 is the square root of t, everything to the third. So when I plug in 4, the square root of 4 is 2, to the third is 8. So this piece is 8 times 2, 16. So then c will equal 8 plus 16, which is 24, minus 64 over 3. So when I move this here, it becomes positive. I get 24. When I move this here, it becomes negative. So now I have 3 times 24 minus 64. C times 3 times 24, what is this? 2 and 1, 6 and 7, minus 64. Correct my numbers always. Yes, I think I'm okay. So then C equals, is it 8/3? Correct me, please, if I'm wrong. Anytime. So S of t, t to the third over 3 minus 2, t to 3/2 plus 8/3. So this was the most general antiderivative. This is one and only one, a unique antiderivative, because it fulfills the given condition, this one. No other derivative will fulfill the given condition and still have that v of t. Do we feel a little bit better? Okay. Do you think we can move on? Can we move on now?
Yeah.
Okay. Thank you. So one comment I wanted to, before I start chapter 5, I wanted to make a comment on your last homework. So please look at the solutions. Always look at the solutions. So my comment was here. Everyone came up with this function. Perfect. But if your calculator is not in radian mode, you got completely different answers, and your method may not even converge. So be very careful in the calculator when you have, if I have just trig functions, it doesn't matter. But you have outside x, so you have to have everything in radian mode. If your calculator is not in radian mode, you're not getting the correct answers. And your method does not converge. You may write only one solution that's 6 point something, but that's not the solution. Because your method does not converge. Your calculator has to be in radians. Again, if you only have trig functions, it doesn't matter. Right? But if you have variable outside of a trig function, everything has to be in radians. So that was my comment about I graded your papers today. Okay, chapter 5. Let me start a new page. I'm not going to put the title because it will take a long time till we get to the title. So the first thing that I want to explain is find area under graphs. What? Why would I ever want to find an area under a graph? Who cares? Here's what happens and why we care. I'm going to choose a very simple function, like let's say x squared plus 1. I'm going to choose a very simple interval, like 0, 2. So what is the question now? Find the area under the graph of this function between 0 and 2. And again, I didn't forget. Why? Why? I'll explain in a moment why. Okay. So first I'm going to graph this function. And I know that it's x squared and then up 1. So at 0, so this is my 1 and this is my 2. So at 0 is 1. At 2, 2 times 2 is 4, 4 plus 1 is 5. 2, 3, 4, 5. So I get this graph. So here's my graph. This is the graph only between 0 and 2. I don't care to look at anything else. I'm not interested in anything else. So I want to determine this area. I want to answer the question right now. First of all, why? Here's why. Remember the process of anti-differentiation? So a few minutes ago, we chose a problem in which we were given v of t. And we wanted to determine s of t. If v of t is this function, if v of t is this function, this area is the distance. That's not a good color, sorry. This is the distance covered between, by the particle or the car or the individual, between 0 minutes and 2 minutes, 0 hours and 2 hours, 0 days and 2 days, whatever you want the measurement unit to be, between 0 and 2. That's why we want to learn how to find the area under a graph. So if I want to find a number, not just the function. If I want to find the function, I will just find the antiderivative of this, as we did a few minutes ago. We chose this. We chose this, and we found this. But if the question is, find the distance that I covered between, I don't know, at 6 o'clock a.m. today and then 8 o'clock a.m. 2 hours later, assuming I didn't stop for any reason. If I find this area somehow, and I'll show you how, if I find this area, then I know exactly what distance I covered between 6 a.m. and 2 hours later. So that's one reason why we want to find areas on the graphs. So now what is the mechanism? So first of all, number one, let me see my video here. Yeah, let me